Long before ice houses, cellars, or electricity, entire cultures depended on something most people today fear and discard: fungus. Not the random rot of spoiled food, but specific, cultivated molds that actively protected meat, grains, and vegetables from decay. This was not desperation science. It was deliberate biological engineering developed through observation, repetition, and inherited knowledge. For thousands of years, this fungal partnership kept armies fed, villages alive through winter, and trade routes functioning long before refrigeration existed. Why ancient societies learned to trust certain fungi instead of fearing all mold. Early farmers and foragers quickly noticed a critical pattern. Some molds ruined food quickly, producing foul smells and sickness. Others did the opposite. They stabilized food, improved flavor, and prevented further spoilage. Over generations, people learned to recognize safe fungal growth by smell, color, texture, and timing. This knowledge spread across continents independently. In Europe, Penicillium species protected cured meats and cheeses. In East Asia, Aspergillus oryzae transformed grains into shelf-stable foods. In parts of Africa and the Middle East, naturally occurring surface molds preserved grains and legumes. These fungi did not destroy food. They dominated it, outcompeting dangerous bacteria and sealing the food in a biological shield. How controlled fungal growth prevented dangerous decay. The key to fungal preservation was control. Ancestral methods never relied on chance alone. Temperature, humidity, salt levels, airflow, and timing all mattered. When conditions favored the right fungus, it colonized the surface quickly and aggressively, leaving no space for harmful organisms to take hold. This is why cured meats coated in white mold lasted months or years. The fungus consumed oxygen at the surface, altered acidity, and produced compounds that suppressed bacterial growth. The food inside remained stable, protected by a living barrier. Modern microbiology has confirmed what ancient people already knew by experience. Why fermentation and mold preservation were inseparable practices. Fungal preservation rarely worked alone. It was paired with fermentation. Salted meat, cooked grains, or soaked legumes were inoculated naturally or deliberately, then allowed to ferment under controlled conditions. The fungus converted complex carbohydrates into simpler compounds, lowered pH, and created environments hostile to spoilage organisms. This process is still visible in traditional foods today. Aged cheeses, cured sausages, miso, soy sauce, and certain fermented breads all rely on ancient fungal techniques. What looks like spoilage to the untrained eye is actually a stabilized, protected food system. How ancient people identified safe fungal cultures without science. There were no microscopes or lab tests. Instead, knowledge was passed orally and visually. Safe molds had consistent color, smell, and growth patterns. White, powdery, or velvety coatings were preferred in many cultures. Sharp ammonia smells, black or green irregular growths, and slimy textures were rejected. Families guarded starter cultures fiercely. In some regions, wooden tools, fermentation rooms, or storage vessels were never cleaned aggressively because they housed beneficial spores. The environment itself became part of the preservation system. How you can understand the principle without risking modern safety. It is important to understand that ancestral fungal preservation was precise, not reckless. Today, recreating these methods safely requires education and respect for tradition. The principle to learn is not let food mold, but create conditions where only the right organisms survive. Modern survivalists and historians, study these methods to understand food security, not to gamble with health. Studying traditional cheese aging, koji fermentation, or dry cured meats through reputable sources shows how ancient people achieved consistency and safety without refrigeration. Why did fungal preservation matter in warfare and migration? Well, armies simply could not rely on fresh food. Mold-protected cheeses, dried and fermented meats, and grain pastes preserved by fungi traveled long distances without spoiling. This in turn allowed long campaigns, sea voyages, and, honestly, winter survival. In many cultures, food preserved with fungus was considered elite or sacred. It represented stability, foresight, and mastery over nature. Losing a fungal culture meant losing food security. How, you might wonder, did environment shape different fungal traditions? Cold regions favored surface molds on meats and dairy. Humid regions favored grain and legume fermentation. Dry climates relied on salt and fungal dominance combined. These systems evolved locally, shaped by climate and available materials. This explains why similar principles appear worldwide, but with different species and techniques. The method was universal. The execution was regional. Why did modern refrigeration make this knowledge nearly disappear? Refrigeration removed the need for biological preservation. Food became passive again. Instead of being protected by living systems, it was locked away from decay temporarily. As a result, fungal knowledge faded, surviving only in traditional foods and isolated communities. Yet refrigeration fails during power loss, conflict, or disaster. Ancient fungal preservation did not depend on grids or machines. It depended on understanding life itself. Why does this ancestral fungus knowledge still matter today? In a world facing supply chain instability and climate uncertainty, understanding how humans preserved food for thousands of years without technology is not nostalgia. It is resilience knowledge. It shows how biology can be an ally rather than an enemy. If you value the deep history of survival, World War II, and forgotten ingenuity, subscribe to Echoes of Valor. Share this with someone who studies the past seriously, and help preserve the knowledge that once preserved us.